Alright, what's up guys? Today we got simplifying radicals. The first thing you need to really know are like your square roots. You need to know your perfect squares. So the perfect squares are, very basically, yes, I make mistakes too. Alright, so all of these are your perfect squares 1 through 15. And you can see those over here. On the right side, make sure you get those down, make your life a lot simpler. Alright, so the first thing you want to do when you're looking for a square root is to see if it's perfect or not. And as you see in this first set, 49, 100, 1, 144, 0, these are all perfect. All of these have an answer. So the square root of 49 is 7. Square root of 100, 10. Square root of 1, 1. Square root of 144 is 12. And the square root of 0 is 0. As you can tell, these are all perfect, all easy to see. You can do these in a calculator or you can do them in your head. Either way works. So then we come to simplifying radicals that aren't perfect. And there's a couple ways to do these. I'll show you the long way and then the short way. Either one works very easily. So a radical is anything that has a little radical. Most of the time you call it a square root. Number in front is a coefficient. 10 is your radicand, is an expression. A radical expression is any expression that contains a radical. And to simplify means we're just going to make sure there are no perfect squares left. No perfect squares. None of these numbers are left inside. All right. So we go on to method 1. Very simply find two perfect squares. So 50 very easily is 25 times 2. Well, 25, as we know, is a perfect square. So the square root of 25 is 5. And the square root of 2 is not perfect, so we're left at 5 square root 2. Excuse me. The other way to do this is to do a factor tree. So we get the 50 and we factor it. And we can do the same thing we just did, 25 times 2. 2 is prime. Can't break it down anymore, so we can break this down. 5 times 5. All right, so we see 5 times 5. Those are both prime, prime. So when doing square roots, it takes a pair to get outside the house. A pair to get outside the house. So we've got a pair here, so that one pair comes outside the house. A pair of 5s. 5s come out. 1 5 out. 2 doesn't have a pair. It's lonely. It's got to stay in the house. There you go, 5 square root 2. As you see, same answer, 2 different ways we could do this. Now there's also a third way we can do this if you have a calculator. All right, so if you have a calculator, the first thing we want to do is we want to check and see, is the square root of 50 perfect? So we already know it's not, but anyways, square root of 50, is it perfect? No. All right, so what we're going to do from there is we're going to go to y equals, and we're going to type in what's under the square root, which in this case is 50, and we're going to divide it by x squared. Square root, x squared, that's what we're going to divide it by. All right, and I don't even care what the graph looks like from here. Graph doesn't matter for us on this one. Only thing we're worried about are the table. What is the table? So I'm going to hit second graph. I'm going to look at the table. Now, when I'm at this table, I'm looking for the lowest number under y that doesn't have a decimal. So I'm scrolling down, I'm looking over here. All right, so now I'm below 1. Once I'm below 1, I'm not going to find a number without a decimal. So I'm going back up, and as you see, 2 is the lowest number without a decimal. So here's what you have. When you're doing the calculator, the x value is on the outside of the square root. The y value is on the inside of the square root. Well, what's our x value in this case? 5. What's our y value in this case? 2. And we still have the same answer here, here, and here. Any of those ways work. Doesn't matter which one you try or which way you do it. All right, so just for an example, here we go. You can do one of 2 ways. I'll show you probably the factoring and then the calculator way as well. 45, easy one is 9 times 5. 5 is prime, so we can't do anything with the 5, but 9 I can, which is 3 times 3. 5 is by itself, so it's got to stay in the house. There are a pair of 3s, so that pair of 3 come on out, and you have your answer of 3 square root 5. You could also do it in the calculator if you wanted. Same thing we just did. Square root of 45. Is it perfect? As we see, it is not. So we go to y equals, we do 45 divided by x squared, and we go to our graph. And we're looking for the lowest number under y with no decimal. Well, when I get to 7, I have decimals. Decimal, decimal, decimal. At 3 is the lowest number, 5, with no decimal. So I have 3 square root of 5, which I already know my answer is. Okay? So let's look at number 2. Number 2 has 2 times the square root of 60. All right, so the first thing, I'm not even going to worry about this 2. I'm going to put this 2 over here and a parenthesis. We got to figure out square root of 60. Now, this time, I'm going to do straight calculator. So, square root of 60. Is it perfect? 7.74, blah, blah, blah. No, it's not perfect. So what am I going to do? I'm going to go to y equals. I'm going to type in 60, and I'm going to divide it by x squared. All I'm looking for is my table, second graph. And I'm looking for the lowest number with no decimal. Well, here I'm below 1, so my lowest number with no decimal is 2 and 15. So, the 2 goes on the outside, and the 15 goes on the inside. Okay? So from here I've got 2 times 2 square root 15. Well, 2 times 2 square root 15. Can't do anything with the square root of 15, but I can with these 2 numbers, this 2 and this 2. So 2 times 2, which gives me 4 square root 15. Now just to show you that it's the same answer, 4 square root 15 and 2 square root 60 are exactly the same. Okay. Now you can do this for all of these. The first thing you want to do is you want to make sure and see, is it perfect? Is it perfect? All right? Is it perfect? So first thing I want to do, I'll need to check and see. First of all, I need this negative 3 over here. Is the square root of 54 perfect? No, it's not. So for this one, I'm going to do the little factor tree for you guys. And 54 is 9 times 6. I can break the 9 down to 3 times 3. And I can break the 6 down to 3 times 2. Again, you got to have a pair to get outside the house. No pair here, so I just take what that is multiplied as, 3 times 2. 6 stays in the house. And again, you're at the same position you were over here. We did 2 times 2, so in this case, I'm going to do negative 3 times 3, which gives me negative 9 square root 6. And just to show you, just like last time, we have negative 3 square root of 54. And now we have negative 9 square root of 6. And as you see, same answer. Okay. Number 4 here. 225. Is it perfect? Is it perfect? Well, as we see, we get a perfect answer, no decimal, which means it is perfect. So square root of 225 is 15, and I'm all done. Okay. I'm going to look at number 6. Do this on the calculator for you. 98, square root of 98, is it perfect? We see it is not. It has decimals after it, which means it's not perfect. So I go to y equals 98 divided by x squared. And all I'm worried about is the table. That's all I'm worried about here. So second graph. Looking for the lowest number under y with no decimal. At 10, I've hit below 1, so I need to go back up. I see 7 and 2, which tells me 7 on the outside of the square root, 2 on the inside. And there you go. And they are the same. Okay. Now, obviously, we know this isn't all easy and everything because, we got to throw some letters in there with it. So simplifying radicals with variables. Okay, here you go. If the power is even, divide the power by 2. Write the variable on the outside of the radical to the result. If the power is odd, when you divide by 2, there will be 1 left over. Keep the leftover variable under the radical, and the other will be just like above. So as you see, square root of x to the 6th, 6 divided by 2 is 3. The square root is now gone. 6 divided by 2 is 3, so it's x to the 3rd. M to the 9th. All right, so m to the 9th, 9 divided by 2 is 4, with 1 left over, so that's why we have m to the 4th and 1 left over. So let's look at number 1 here. We've got the square root of 16, x to the 3rd, y to the 6th. So first of all, square root of 16. Is it perfect? Yes, it is. All right. So we've got 4. And then we have x to the 3rd. Now, x to the 3rd, 3 divided by 2, equals 1. And 1 left over. So it means I've got 1x out here, and I've got 1x inside here. And then I have y to the 6th. 6 divided by 2 is an even number, obviously, so 3. So that comes outside as well. Let me slide over and give myself some more room. So I got 4x, y to the 3rd power, and there's your answer. 4xy cubed square root x. Okay. Same thing for 2. So the first thing I'm going to ask myself, is it perfect? Is the number perfect? So I see the number is not perfect. So I'm going to go to y equals 124 divided by x squared. And I'm going to go to my table. And I'm looking for the lowest number under y. And there we are. So that means 2 goes on the outside. And on the inside, it looks like it's 31. Now we're going to do the same thing with the variables we did over here. So x to the 4th, that's an even number. 4 divided by 2 is 2, so that's going to be x squared. And then we have 7, which is an odd number. So 7 divided by 2, 2 goes into 7 3 times. And we're going to have 1y left over. And there we go. And there's our answers. Okay. Now just remember, if you got questions, you can email me. And if I can't answer it in an email, I can do a video just like I'm doing right now, and I can video it to you as well. So just remember that. All right, so we're going to do one of these at the bottom here. And we'll look at, let's look at number 5. All right, so just like before, the 4 goes into a parenthesis, and then we got to work this out.